Okay, 2.8, graphing inequality. So let's go to this worksheet. So all they want me to do is shade the appropriate side. So the shortcut to this, let's do that, is this is a less than sign. So it's less than, so I'm going to shade below the line. So all we're going to do is shade below. Like that. The next one is greater than. X is greater than 2. So I think when I say the greater, I think greater than, like you're greater than the line. It's like here was less than, right? You're less than the line, so you're below it. You're greater than the line. Now here's going, it's up and down, so what's greater than? Another way to think about it's the numbers, right? Here's 2, here's 1, here's 3. Which side's greater than 2? This side is. So that's what we're going to shade. The next one. So again, I just want to shade less than. So here's my graph. I want to be less than it. I'll be below it. And if you're not sure, another way to do, you can always do a test point. So like do a point somewhere. Let's pick a point like out here. Let's pick 0, 0. That's probably the easiest one. Now, if it's true, I shade that way. If it's false, I shade the opposite one. So let's plug in 0, see if it works. So I get 0 is less than negative 2 times 0 minus 5 plus 1. So that'll be 0 is less than negative 2 times absolute value of negative 5 plus 1. That'll just be 5. 5 times negative 2 is negative 10 plus 1. So I get 0 is less than negative 9. That is false. So I do not shade where the point's from. I shade the other portions right here. So both ways I get the same answer. Right, so you can always pick a point, plug it in, see if it works. If it works, you shade. If it doesn't work, you shade the opposite choice. Or like I like to do, less than means below or less than, so you're less than this line, so below it. So let's do that here. Right, here's my line. I want greater than, so I want to be greater than this line, so I want to be above it. Here, same idea. Now it's a little funkier. These are funkier ones. So the reason I did it like this, because this works when it's in proper notation. Right, the less than below with the y is on the left hand side. Proper notation. When it's not in proper notation, oops, sorry. It's a little funkier. You can't just go left and right because it's not in the proper notation. Easiest way to do with these is pick a point. So easiest point to always 0, 0 if you could use it. Let's plug in 0, 0. Over here I get 0 is greater than 2. That's not true. 0 is not greater than 2. So I don't shade here. I'm going to shade the opposite. So the next one, again, not in proper notation. So I'm just going to pick a point. Good old trusty 0, 0. Now one cannot pick 0, 0 if 0, 0 was on the line. Like I can't pick 0, 1 here because it's on the line. So I have to pick something else. Like here I couldn't pick 0, 2 because it's on the line. You have to pick something that's not on the line. So I've been lucky. 0, 0 has not been on the line. So plug in 0, 0. I get absolute value of negative 2 minus 1 is greater than 0. That's just 2 minus 1 is greater than 0. So I get 1 is greater than 0. That is true. So I do want to shade where I picked my points. I'm going to shade all this. There. Circle. Now, I like to think about it this way. So this is less than. So if you're less than the circle, what do you shade? I would shade inside. If you're greater than the circle, you shade outside. But if you're not sure, pick a point. Go to trusty 0, 0. I can pick the center if I want, actually. But we'll go 0, 0. So 0, 0. Negative 3 squared plus 1 squared is less than 25. So I get 9 plus 1, because I already squared everything. It's less than 25. That is true. So I will shade the inside. So there we go. So again, two ways to do it. Generally, with the proper notation, it's just easier to understand that, okay, less than means you're less than the line they give you, so shade below. Greater than means you're greater than the line they give you, so shade above. If it's not a proper notation, then just pick a point. Easiest point is always 0, 0. If it's possible, if not, pick a different point. If it works, shade. If it doesn't work, shade the opposite. So now we're going to do all these, right? We're going to graph the inequalities. So all we got to do is just graph it first, so put in proper notation. So let's make it 2y is greater than negative x plus 6. All right, put in slope-intercept form. It's the easiest way to graph. Got to get rid of the 2 still, so divide everything by 2. Not just the 6, everything. So y is greater than negative 1/2 x plus 3. So plus 3. Right, that's my y-intercept. My slope is negative 1/2, so down 1 over 2. At negative 1/2. Rise or run. It is a dotted line. I see no equals to sign, so I'm going to make it dotted. And then it's greater than, so shade above. So there we go. Next one's a little weird. It's x greater than -6. So here's my x. Go to -6, which is like right here. And then just follow the tally marks. That's the way I always do when it says x greater than. So follow tally marks. Like if you're doing tally marks, right? Up and down. So there's my line. And I'm greater than equal to, so I'm a greater than sign to the right. So solid, and then to the right. There we go. Next one, again, I got to put in proper notation. Get that y by itself. So -3y is greater than -4x plus 12. Divide everything by 3. -3 actually. And since you divide by negative, the sign flips. So it becomes y is less than 4/3 x minus 4. And there's a little messy on the side here, sorry. That's what's going. That's what you should get. So start at -4. My slope is 4/3, so up 4/3. It is dotted, no equal to sign. And then since we divided by negative, I switch the sign, so now it's a less than, so I'm going to shade below. So like that. These, y is less than absolute value of x minus 3 plus 4. So remember, this is the like lesson we talk about moving left and right, right? So inside opposite plus 3, to the left 3, and outside follow plus 4. Easy way to think about it, that's like your vertex, right? My vertex is 3 and 4. When I'm starting at 0, 0, I'll go into the right 3, and I'm going up 4. So that's where I should start. Then absolute value is a v, and it's solid. So like this. And it says less than, so we're shading below. That was supposed to be, there we go. Next one, y is less than -2 times absolute value of x minus 3 plus 1. So again, kind of like what's our vertex, right? Inside opposite. So inside opposite, positive 3, outside follow 1. Right? Take your normal graph, and you move it right 3 and up 1. Now it is a v, but it's a -2. So remember what that does? That's like your slope. We're going to go down 2 over 1, down 2, left 1. Right? It's a vertical flip, plus we're multiplying by 2. So it's like our slope, down 2 over 1, down 2, left 1. And it is dotted. And then less than, so we're going to shade below. And if you're not sure, you can always just pick a test point. Okay, let's move on to the next one. Application problem. April's guidance counselor says that she needs a combined score of at least 1,700 on her college exams to be eligible for the college of her choice. The highest possible score is 2,400. There are 1,200 possible points in the math portion, 1,200 points in the English portion, verbal portion. The inequality x plus y is greater than 17% this situation, where x is the verbal score and y is the math score. Graph this inequality. So graph this how we did the rest, right? So get y by itself, so subtract x from both sides. So I get y is greater than or equal to a -x plus 1,700. Like that. So we're going to start our y-intercept is at 1,700, so right there. Our slope is down 1 over 1, so like that. So something to this effect. And it's equal to, greater than. So solid. Something like that. And then it's an inequality, so you have the shade. It's greater than, so I'm going to shade below. So above, sorry. So I can get better than that. Anything over here is fine. Okay. Refers to the graph. If she scores 6.8 on her math portion, come on, girl, of the test, and 9.10 on the verbal portion of the test, will April be eligible for the college of her choice? So we're just going to use a graph here. I changed it a bit. My graph wasn't as accurate as I fixed it up now. But let's go 910 verbal. So like here's 900, so down here, and 680, so a little bit before 700. So about here-ish. That's where she'll score. So no, she's not going to be eligible for the college of her choice. She has to get that math score up. Or the English score up, I guess. Next one. Graph each inequality. So these are trying to be tricky. Notice how that the y's on this side, we normally have on the opposite side. So if you move it over, it's y is less than or equal to x minus 2 minus 4. So like we talked about, right? Inside opposite, outside follow. You start at 0, 0. You're going right 2 and down 4. So that's kind of like our vertex. And then from there, it's an absolute value. So let's make a v, and it's equal to, so it'll be solid. And then it's less than show shade below. Same with this one. Let's move that 3 over so you can see it in the graphing notation. Vertex notation, actually, it's called. Then we know, okay, inside opposite -4, outside follow 3. So right, start at 0, 0, you go left 4 and up 3. Around there. This one does have a vertical shift, and it's a flip also. See, it's negative, so it's up and down, and it stretches. Easiest way to think about this, think about it like slope. So right, -2 over 1. We're going to go down 2 and over 1, down 2 over 1 the opposite way. This is not equal to, so it's a dotted line. So like that. And then we're going to shade this greater than, so I'm going to shade above. So there we go. Next one, write the inequality for each graph provided. So they want to write inequality for all 3 of these. So this first was just line. So the key thing here is just find the equation of a line. And we do that like we always do it. Find 2 points. Right? Do y equals mx plus b works. In this case, I'm not going to do mx. I'm not going to do great equals to. Look at the way it works. We're shading below, so it's a less than sign. We're going to do less than, and it's a solid line, so we're going to make it equal to. Now all we got to do is find the slope and the y-intercept. Well, the y-intercept is 3. And then our slope, we just got to find it. Over 2, up 3, so slope of 3/2. So there we go. That's my equation. You could do point slope form, but remember, when you have a graph, it's usually easiest to do y-intercept form. Slope-intercept form. Okay, the next one. Well, what type of graph is it? It's a parabola. Parabola. It's an absolute value. So it looks like this. Right? Notice how it's shaded below, so less than, and then it's not solid, it's dotted, so it's a less than sign. Like that. Now what's going on? We're staying down, we're not moving anywhere, we're moving left and right only. So this is +4, but it's going on the inside, left and right, so we're going to put a -4 in there. Inside opposite. Something like that, right? It's not going up or down anywhere, so it stays alone. You move it to the right, so that means inside opposite, it's a -4. Next one, kind of like the first one, right? It's a line, so we're going to do y equals mx plus b. We're shaded below again, and it's a dotted line, so just like this. What's our y-intercept? Looks like it's 0. And what's our slope? We'll pick 2 points across nicely. 2 and 2, so our slope is 1. So we just get y is less than 1x, or just y is less than x. There you go, and that's the lesson.